So now that you've made many causal loop diagrams, we can actually continue with the course and really get started with quantitative simulation models. I already opened VenSim. Again, this is an older version. I'm waiting for my other computer to be used. In any case, in the old version or the new version, you start a new model. And here it becomes important to specify the initial time, the final time, the time step, units of time, and the integration method. In this case, I'm just going to make a very simple model, but even then, it's important to decide about the settings. I'll come back to this in the second week. The types of variables that we use in these simulation models are stocks. So that's a variable with a box around it. And they are actually variables that accumulate stuff, whatever it is, people, material, and they accumulate whatever flows in over time. So that's an inflow minus everything that flows out over time. So this is an outflow. Then we have auxiliary variables, and they are just there to make the equations in our model easier and to relate the models to the real world. We also use normal blue single arrows. They are just causal links as we've seen them in our causal loop diagrams. And say for instance our stock causes the inflow in a positive way, then the bigger the stock is, the more inflow we will have, and that this stock actually has a negative causal link to the outflow, then this means that the bigger the stock value, the larger the outflow will be. Oh, sorry, I wanted to say a positive link. So let me change that, click right, and this is positive. Then how does this relate to our causal loop diagram that we used in the first part of this week? Well, I can actually make the corresponding causal loop diagram by just using the same variables, but you cannot actually define variables twice. So what I'm doing here is to add a little dot at the end. You can do so in another view though. Oh, there we go again. So dot and the auxiliary. Now the stock, between the stock and the outflow there is a positive causal link. So the bigger the stock, the bigger the outflow. But if we look at our stock flow diagram, then you also see that the bigger the outflow is, well, therefore the smaller will be our stock. So there is a negative causal link between outflow and stock. So let me indicate that here with a negative arrow. And knowing from the first part of this week, looking at this feedback loop, we have a negative feedback loop. So I'm immediately going to add the symbol for that. So this is a clockwise negative feedback loop. And I can also give it a name if you want to. And that actually makes communicating about these loops much easier. On the other hand, the stock, between the stock and the inflow, there's also a positive causal link, and between the inflow and the stock, well, there's an inflow, so the bigger the inflow becomes, the bigger the stock becomes. So this is also a positive link. This basically means if we add another loop, so this is a counterclock loop, that we have a model consisting of two loops, a positive and a negative feedback loop. And then we may at this point actually start to think about the possible behaviors this system could generate. Knowing from the first part of this week that the positive feedback loop leads to exponential increase or decrease, this could basically mean that if this positive feedback loop is always dominant in this system, that you just get that behavior. Or if the negative feedback loop is always dominant, you could just get convergent behavior to some particular value. It could also mean that if the positive feedback loop is dominant and then the dominance shifts towards the negative feedback loop, that you get some sort of S-shaped growth. This is also what you need to do each and every time that you are making a simulation model, that is to think through the possible behaviors that could be generated. There are also some very exceptional types of behaviors that can be generated with this model, namely constant behavior, for instance, where the stock variable just remains 0. That's possible as well. Just to show you the connection with your mathematics classes, but this is really not the core of this course. I could actually write down the equation that we see here as being a differential equation or an integral equation. In this case, let me go for the differential equation, and then it basically means that the behavior of the stock over time dt is equal to everything that flows in minus everything that flows out, and everything that flows in is in this case the inflow minus the outflow. So now we can actually integrate this equation and get the behavior over time. So I can also write the integral equation. I'm not going to do that here. So this is basically the start of our quantitative modeling. You have the core structure of the model now, but you still need to fill in the equations. So then you would have to click on the equation editor, and then you can fill in all the equations that are here. Now, very good practice when you're making models is to make sure that even all initial values and constants are also visible in your model, that they are outside of your equations. So for instance, the stock variable, if it has an initial value, so I will give it initial, I will put it outside of my stock and link it up to my stock. When I fill in my equation later on, you will see that this arrow disappears or becomes light gray. It basically means that this value, this constant, is not going to change the behavior of my stock over time. Stocks can only be changed over time by inflows and outflows. So in this second part, you need to just follow the learning path as well. You will follow a couple of tutorials, and then you will get to exercises. For instance, exercise 6.1. So this is about cocaine in a country. It's of course very simplistic, but let's quickly do this exercise.